Alright guys, so today we're going to talk about slope and rate of change. So over the last couple of days we talked about the distance formula. Remember that the distance formula is distance is equal to rate times time. Well, we know what distance is, we know what time is, and it's this rate. So rate is really, in its bare sense, getting from one point to the other. So now I'm going to bring you guys back and introduce something called slope. Slope is basically the same thing as a rate, but more importantly it's a rate of change. And the rate of change is used from situations, but in this case we're going to use slope for a graph. The most important thing about slope is that I want you to remember that slope is always going to be some type of unit rate. Okay, so on the, please add this to your WIS and keep it in your composition book. Slope is the rate of change. Here I have a triangle and a triangle. Triangle in math literally means delta, in this case delta y divided by delta x. Delta just means change in. And we'll talk more about it in class, but Delta Airline used their slogan used to be Delta, changing the way we fly. So this is the change in y divided by the change in x. Okay. Next, we're also going to use a slope triangle. You can only use a slope triangle on a graph. It works for all quadrants. But slope is the change in y divided by the change in x. Luckily, when you have a graph, it's really easy to find one point on the graph to the other. All you gotta do is find the vertical change first and then the horizontal change second. I just want you guys to remember this. It's kind of like walking up a steps or set of stairs, or walking down a steps. So from here, if I wanted to, I could do the same thing, do the same slope, and it will always give me the point on a line. The reason why we use slope is to get from one point of the line to another, and it will always be on that. And slope is just giving us that unit of change from one point to the other. Next, we have our first example. So here we have toothpick squares. We'll probably go over this in class as example, but on the camera right now you'll see the number of squares and the number of toothpicks. So here I know that for one square I have 4 toothpicks. Kind of makes sense. For 2 square I have 5, 6, 7. I have 7 toothpicks, and then so forth and so forth. They'll ask you to find the slope on this graph. To find the slope on a graph, we're going to use the slope triangle. This is the first method of finding slope. We find one point on the graph, find a second point on the graph, and then we find I'm going to draw it on the graph for you to see, change in y over the change in x, and write equal. So the change in y is, if you're going back to the diagram there, we're going to find the number of jumps to get to the next one. So the change is 1, 2, 3. Draw my little triangle so you guys can see it. Okay, so that's a 1, 1, 2, 3. That's a change of 3. And then the change over here in my x, going over once, that's 1, is 1. Okay, so that my slope here is 3 over 1, or just 3. To double check to make sure that I have the right slope, I'm going to use 3 over 1, and I should hit every point on that graph. So 1, 2, 3 over 1, yes. 1, 2, 3 over 1, yes. One more time, 1, 2, 3 over 1, yes. So I know I have the right slope. My slope is 3. Let's go to the next example. Okay, finding the slope right here. Just another example on a graph. It really works on any point on your line that's on a graph. I recommend that you always use a point on the graph that you know for sure. So for example, I know this point for sure. These right here, you can tell that they're not really on where they intersect, so I'm not really sure, so I'm going to use the points that I know for sure. That one, I know that one's at 0, 0. I know that one's 3, 2. So let's just do the one that I highlighted for you. So we're going to find the change in y first, and then we're going to do the change in x. Okay, 1, 2, so that's a change in 2, and then 1, 2, 3, that's a change in 3. So my slope is 2/3. In math slope, we use the letter lowercase m, 2/3. And we got to double check. if I go 1, 2 over 1, 2, 3, my point is right there, and if I were to continue my arrow, it would hit that slope. The cool thing about slope is it's positive, and you can work backwards and make it negative. I can fall down 2, so falling down 2. So if I were to change in y over change in x, if I go down 2, that's negative 2. 1, 2. And if I go down over to the left 3, that's getting smaller. 1, 2, 3. That's a negative 3, and that's a negative 2. Well, what's negative 2 divided by negative 3? Let me do it in red. So watch here. From this here, 1, 2, that's a minus 2. And then going to the left is negative 1, 2, 3. That's a negative 3. Because we're going on the, remember that the x and the y-axis are just actually two number lines that intersect. So we have a negative 2 over negative 3, and you know a negative divided by negative. Negative 2 over negative 3 is still 2/3. So my slope here is 2/3. Okay. I'll let you go ahead and do this one. If you want to pause the video and then check your answer with mine, that would be great. I'll pause here for a little bit. Okay, so let's find the slope on this one. I know this point for sure, this point for sure. I don't really know about the other one, so I'm going to go here. I'm going down. You can go up, but really you can't go up because it can't go anywhere. So I'm going to go down 1, 2, 3. So change in y over the change in x is negative 3. And I'm going to the right, so that's a positive. 1, 2, 3, 4, 5. So that's positive 5, negative 3. So my slope is negative 3/5. Okay. If you want to do it the other way, it should work as well. 1, 2, 3. So that's plus 3. So do the different example over here for you. You see how if I went up, that's positive 3. But then I got to go to the left, so that's negative 1, 2, 3, 4, 5. Negative. So here, 3 over negative 5 is still negative 3/5. Remember that as long as you have one negative in your numerator and denominator, the whole fraction, the whole ratio is negative. Okay. Another way, some teachers have said this, and I will continue to say as well, slope is defined as the rise over the run, but we know specifically is the same thing as saying delta y over delta x. So now let's take it away from a graph. So obviously you guys can always graph the 2 points and then find the rate of change or the slope on the graph. But if you don't want to graph 126 and 72 because that's such a big difference from each other, we are going to also make a t-chart. And I'm going to go ahead and write change in y over change in x, and it's got to be y over x. And we'll talk more about that in class. I'm going to write my first point. It doesn't matter which one. 7, 2. 7, 2. I know 7 is x, 2 is y, 1 is x. It's y right there. I'm going to write the second one. And then what I'm going to do is I'm going to do a little bracket. So how do I get from 7 to 1 on a x number line? That's minus 6. How do I get from 2 to 26 on the number line? That's plus 24. I'm actually just counting how many times I jump on the number line. And I know that it's change in y over change in x. So the change in y is positive 24. And the change in x is negative 6. And you always simplify it. So 24 over negative 6, my slope is negative 4 over 1. Okay, look what I just did. Made brackets, find the change from my y1 to y2, then find the change in y1, x1 to x2, and then just put it. Common mistake here, a lot of students end up putting negative 6 over 24. Remember, that is not correct because that would be x over y, and that's not correct. Okay, got one more example for you, I believe. For each coordinate, find the rate of change slash slope. So I'm not wanting to graph this, make a t-chart. Here's x1, y1, x2, y2. And it doesn't really matter which one's x1 and y2 because eventually you'll get the same slope if you do it correctly. Negative 3, negative 3, negative 5, negative 9. Okay, these are just basically the ordered pair that I copied into my t-chart. How do I get from negative 3 to negative 5? Well, that's a minus 2. How do I get from negative 3 to negative 6? That is a minus 6. Okay. because basically we're just playing with two different number lines, -3 to -6. I'm not adding 6 because -3 plus 6 would be +3. I need a -6 to get into the more negatives. So what was slope defined as? Change in y over change in x. Change in y is -6. Change in x is -2. I simplified that down. -6 over -2 is 3. Some students like to write it as a fraction, it's 3 over 1. This just means if I'm going to graph it somewhere, I'm going to go up 3 and over 1. Slope is just a unit of change, unit of rate. It tells me how to move, kind of like our distance formula. Okay, last bit, a little common mistake. You already know it. Most students will do it perfectly here. Go -3, 4, -5, -9. Find the change in both. -4 to -9 is -13, and then -3 to -2 is -2. So here we go. Common mistake. Most students will do this first, change in y over change in x, but they actually just reverse it and write left to right. That'd be -2 over -13. Got to be careful. Got to check. This is not the change in y over and change in x. -2 over -13 is actually change in x over change in y. So this would be wrong. Common mistake is students always put x over y for slope. Slope is not x over y. It's change in y over change in x. We can quickly go into the reason why. For example, if I have distance is equal to rate times time, to solve for rate, I divide both sides by time. This relationship here is called an independent variable over my independent variable. In other words, if I'm going to graph this, this is my y-axis over my x-axis, and really that's partly in summation y, in summary y, it's y over x. So that's all I have for you today. Make sure you whisk this, and then we'll talk about it.